So there's one last thing I'd like to tell you while we're going through definitions and properties of estimators, and that's about what we call, there's a special word for the standard deviation of an estimator. We call it the standard error. So the standard error of X bar, for example, is sigma on root n. We worked that out before. So because the variance of X bar is equal to sigma squared on n, the standard error of X bar is sigma on root n. It's helpful to use this terminology talking about the standard error of X bar as opposed to talking about standard deviations, because this is the standard deviation of our data sigma. Sigma is the standard deviation of our data, but if we were talking about the statistic X bar and how it varies from one sample to the next, the standard error of that is sigma on root n. So just using a slightly different term for it, just to emphasize that we're talking about the standard deviation of a statistic when we look at it from one sample to the next. We call that the standard error of the statistic. And sometimes we can't get the standard error exactly. Sometimes we have to estimate it. So, I mean, sigma on root n, if we don't know what sigma is, we can estimate sigma using S. So an estimate, and you might call this SE. Some people would call this SE of X bar. Or SD. Okay, could call it SD, I guess, if we want to. I prefer calling it SE personally. I like the idea of saying SE. So the estimated standard error of X bar, if you don't know what sigma is, I guess you could estimate it. You could say the estimated standard error, we put a hat on top of this because we're estimating the standard error, is then S on root n. If you don't know what sigma is, you estimate it using S. Gives you S on root n as your estimated standard error. Okay.